Today we'll discuss about the laminar flow. Now before going into the session, we need to discuss some basic ideas. First, the difference between the ideal fluid and the real fluid is the viscosity. That means where the viscosity is 0, we'll say the fluid is ideal. When the viscosity is not equal to 0, we'll say the fluid is real. Now if we take an example such as Bernoulli's equation, where we take an assumptions the fluid is ideal, but the practical case is all the fluids are real fluid. That means there is a viscosity. For encountered that viscosity, we'll modify the Bernoulli's equation. So if it is a pipe and if it is a section 1 and section 2, we modify the Bernoulli's equation like P1 by rho g plus V1 square by 2g plus Z1 is equal to P2 by rho g plus V2 square by 2g plus Z2 plus HF, where HF is the heat loss due to the friction and is equal to FL V square by 2GD, where L, V and D are length of the pipe, velocity of the fluid flow and diameter of the pipe. But F is the coefficient of friction or friction factor, which is unknown to us and which can be find by two ways. One is in the experimental approach, another is numerical approach. The experimental approach we need to create a setup. That means a physical setup is needed. And we will perform the experiment for find out the specific values of friction factor. But we could not able to find out different properties of the fluid such as pressure, velocity, shear stress at the different point and different time. That means when it is a function of time and space, we cannot able to find out at each and every point. For that case, we'll go for the numerical approach. Where we'll create a domain and we'll study over the domain, which is control volume, and study and we'll able to find out a pressure, velocity, shear stress at each and every point within the domain. That's why numerical approach is more convenient and easy than the experimental approach. Now, fluid flow can be divided into two types. One is laminar flow, another is turbulent flow. The laminar flow is a flow in which the fluid is flowing in thin or sheet layer or a laminar, smoothly sliding over one another. That means if we able to discretize a specific domain into number of sheet, when the fluid is stagnant. Now when the fluid start to flow, what will happen? One sheet will glide over another sheet So this sheet is gliding over this sheet, and this sheet is gliding over another sheet. This type of flow is known as a laminar flow. Where the mass momentum transfer is absent. Where the mass momentum transfer is absent. That means this will happen only when the velocity is low. When the velocity is high, the momentum obviously will be high. Therefore, the fluid will transfer from one layer to another layer. Say this is one layer and this is another layer, and fluid particle will transfer from one layer to another layer. And this type of fluid flow is known as a turbulent fluid flow. Okay. So basically this laminar and turbulent fluid flow is related to the real fluid flow, where the viscosity mu is present. So for study the laminar flow, there are so many types of system. We'll choose two types of system. First, laminar flow through a cylindrical section, and second, laminar flow through a parallel plate. Okay, thank you very much. For the next session, we'll discuss about the laminar flow through a cylindrical section. Thank you.